All right, so to summarize, there's a couple of different heat transfer phenomena that I discussed in this video if you weren't familiar with them before. Radiative heat transfer, quite poor at removing heat. Convective heat transfer, both natural convection, which is driven by buoyancy, and internally and externally forced convection that can achieve higher heat transfer coefficients. Phase change heat transfer is an excellent way to transfer heat. In fact, in many cases, the transfer is so fast that you become dominated by other processes. Interfacial phenomena may be important for some materials. So in nanoscale materials, it's certainly important, and especially if you need to if you're not joining materials using adhesives or something, it can become quite important even for normal mechanical applications. All of these can be characterized using a heat transfer coefficient, essentially just defined as the proportionality constant between heat flux and a driving temperature difference. The heat transfer coefficient itself, because there's so much different physics involved, really depends on what the situation is, and we'll spend a pretty good portion of the end part of the class trying to come up with different ways to figure out what the heat transfer coefficient is in different convective and phase change heat flow situations. So that concludes this video. So right now we're going to go back and do a little bit more conductive heat transfer before we worry about calculating these heat transfer coefficients. And let's do it.